So now we discuss two-dimensional basis functions, and if expected distribution of function can be described as separable into the two dimensions, we may express them separately for x and y, and functions from x and from y may be expressed in terms of one-dimensional subdomain functions. Again, if we can separate them, and we now describe some types of them, some most common examples. And it can be pulse basis function, and in this case, this pulse basis functions along x direction and along y direction, and they can be given by these formulas. So we have separate intervals hx and hy. So this is how subdomain lengths along each of this direction. And then the pulse subdomain basis functions for the function is defined over cell pairs shown here. Okay, so next is rooftop basis function, and these basis functions are one of the most common in two-dimensional basis functions. So rooftop basis functions is a combination of piecewise linear function along one direction and a pulse function along the other direction. And for piecewise linear variation along the x direction, we can write expression like this. And again, this subintervals that are defined like this, and the pulse variation along the y direction is defined by this expression. And the rooftop basis function gx and gy are plotted here. G. So the last type we consider here is piecewise sinusoidal pulse functions. And so this basis function is a combination of piecewise sinusoidal and pulse basis functions. Right, you can see it. And for this type, variations along the x direction defined by these expressions, and we have k is a constant. And the pulse variation along the y direction is defined by this expression. And again, these are examples of them. So now we move to the type of entire domain. Functions are defined over the whole domain, and the range of space variables over which the problem is defined. So this expansion of basis functions employed in an analytical method of entire domain type and orthogonal in nature. One may also use general orthogonal functions such as Bessel function, Chebyshev polynomials, power series. The use of anti-domain functions are supposed to make the analysis more efficient because only the first few functions may be needed to approximate the functions to the desired accuracy. And then efficiency improves if the expansion functions match the eigenfunctions of the problem. And the anti-domain basis functions are useful in describing smooth variations such as those on the unloaded rectangular shaped geometries or circular patches. The fast variant distribution may also be determined using subdomain basis functions. And model for later use is a single term anti-domain function. That's for the case of charge and current distribution on a strip or slot. So first we talk about series expansion. Basis function is the H singularity. The series expansion defined as this case, and this is a more general form of expressing an unknown distribution. One may write a power series expansion of one-dimensional function in this way, and W is a domain size, and for the basis function to present an even symmetric distribution in X, only even values of n should be selected. And the above basis function can be easily Fourier transform for the use in Fourier transform methods. So we are going to describe some efficient basis function used in the study, for example, for metal strips and slots. So if we talk about basis function with H singularity, then we consider an infinitely long metal strip. It has width W, and this metal strip is typically a microstrip line or coupling waveguide. Can be also printed dipole antenna. So the charge density distribution on the strip can be described by a single basis function, like this. And we can see that the function models a symmetric distribution with the charge density suddenly increasing at the edges, right? At the point where X equal plus minus W/2. So we call this behavior singularity. And we know that it occurs due to Coulomb forces of repulsion between the charges at the edges. And similar behavior of the current distribution is observed along the length of the wire.